first thing is remind you that we have our test Friday. Today we're finishing 4.3, which is relating tables and graphs to equations, vice versa. So what that being said is, yesterday we looked at a table and we were able to graph it and write the equation. Our focus today is I'm going to give you a graph. You're going to need to be able to put the information into a table and write the equation. And lastly, I will give you an equation or a word problem. You'll write the equation, fill out the table, and graph it. Okay, so we'll be able to do all of that. But the first thing that we need to go over is the daily review from today. Both questions, the last time I looked, 58% of the people got both questions right. Same amount of people, 58% of people got it correct on number 1. 58% of people got it correct 2. Okay? So it's important that we know how to do these problems. This is an order of operations problem. The first one, simplifying the expression. We need to use GEMDOS. Okay? If you can solve this problem, it shows me that you have an understanding of GEMDOS. If you can't, then you don't understand GEMDOS. Okay, so let's go through it and make sure you ask questions if you are still confused. 20 plus 8 divided by 4 times 2. What should we do first? Hudson. Division. Why are we doing division first? Someone else. Becca. Good. So no grouping. No exponents. Multiplying and dividing are in the same group. You work from left to right. So I start here. That's an addition. We're not there yet. Here's a division sign. 8 divided by 4 all together. 2. Bring everything else down. What is next? Aiden. Good. 2 times 2 because we're still on the multiplying and dividing. Work from left to right. Addition, we're not there yet. There's multiplication. We get 4. Bring everything else down. We should 20 plus 4 get the answer of 24. Okay, since 58% of you got it right, that means almost half of you got it incorrect. Does anyone want to share what they did wrong so that we can learn from our mistakes? Ella, thank you.
I multiplied 4 times 2.
Good, we did multiplication first. Okay, so again, that goes back to, in the same group of multiplying and dividing, you work from left to right. Adding and subtracting is the same thing. Good? Okay. Parker.
I just tried to go too fast and I accidentally put 2 times 2 equals 8.
Okay, 2 times 2 equals 8, yep. So again, that's another part of these problems. Right? You know how to do it and make sure you solve them correctly. Josh. So you just work straight from left to right. Okay. Again, use that order of operations. Work from top down. GEMDOS all the way down. Tom. 2. Okay. Good. So take our time on those kind of things. I know you know those facts. Okay. Just take your time. It's not a race. Aiden.
What I did was on the second one, I was doing the ladder.
Oh, we're not on number 2 yet. Number 1.
I didn't mention it.
Any questions? Number 1. All right, number 2. Find the least common multiple of 6 and 8. What is one method you can use to solve this? Also known as LCM. Maddie.
If you write down 6 and 8, and then you start writing down multiples.
Good. So this is listing the multiples of 6 and 8. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. Multiples of 8. 8 times 1 is 8. 8 times 2 is 16. 24. 32.
That's a weird. That's 96.
Okay. Okay. Then we have to find the least common of these. So the smallest number that they have in common of their multiples is value 24. Okay, so that's listing the multiples. What's the other way? Sydney. Awesome. Ladder method. So 6 and 8 create our can we divide out of 6 and 8? Tom? 2. That gives us a 3. This gives us a 4. We can't divide anything else out. So how do you find the least common multiple in the ladder method? Emma?
You multiply
All the numbers on the outside. So 2 times 3 times 4 is 20. All right. Any questions, comments, concerns about this? We need to be able to do these 2 problems. Again, you all did a great job on least common multiple for the test. You were able to do questions that were way more challenging than 6 and 8. That being said, we need to make sure we are retaining or understanding, remembering the things that we did in the past. Okay, we can't just forget how to do them. Okay. Good there. Again, remember, this question is not in your guided notes. Just follow along. So not answering anything on the guided notes.
You can also use a graph to write an equation that represents the relationship between 2 variables. To start, use the points on the graph to make a table. The first point on the graph is at 0, 10.
Okay. So, in this problem, they've given us a graph with points on the graph and created a line. So, from this information, what can we get? Emma?
It's going down, so it's probably subtraction.
It's going down, so it's probably subtraction. Good, I like that observance. What else can we take? Hudson?
It could also be division.
Could be division. What information can you take away to help us create a table and an equation? Think about yesterday. We went from a table to a graph. What did we use? Aiden. Raise your hand.
I was raising my hand for something else, and then you said it.
Okay. All right. So what we can do is we can write the ordered pairs from our graph. So they give us the first one. The ordered pair is 0, 10. What is this ordered pair? This one. Lily.
Over 1 up 7.
Up. So the ordered pair would be, what is the x value?
1 is 7. Oh, 9.
Good. 1, 9. What is this ordered pair? Hudson.
2, 8.
2, 8. And what's the next one? Tyson. 3, 7. And Lauren, what's the last one? 4, 6. Okay, you can take that information. What do you think we can do with those ordered pairs? Jason. Make the table. Again, in an ordered pair, it is the x, comma, y. So what do you think would be the first numbers in this row here? Jacob? 1 and 9. You got it. In the second row would be Brogan? 2, 8. The third row? 3, 7. Ben? 4, 6. And we have 3, 5. You can go on. So that is taking how you take the information from a graph and put it into a table. You use the ordered pairs. Every graph that we give you will have points on it. Use those points to write ordered pairs, which then goes into your table. Yes? It just would be 3, 5. Oh. 5. Yeah, 3, 5, 5. Okay? Is that what else had their hand raised for? Okay. Thank you. Good catch, everyone. All right. So now what I want you to do, we need to come up with the equation. Play this a little bit. Fast forward.
The second point on the graph is at 1, 9. Look for a pattern in the table.
Okay, so what is the pattern in the table?
Write the
here?
relationship in words. The number in the X column plus the number in the Y column.
Okay, it's giving you the pattern. What I want you to do with your neighbor is write the equation that goes with this pattern. What is the equation for this table and graph? All right, who has an equation for this table and graph? Play. Y equals X plus 10. Can we check and see if our equations work? Yeah, we're going to plug in numbers that are in the X. They have to equal the Y in this case. So when X is 0 plus 10, is the Y correct? That one works. Do we have to do more than just one? Yes, we should do 2 or 3. Should do 3. So X is 1. 1 plus 10, does that give us 9? 1 plus 10, does that give us the 9? No. So if it doesn't work once, it won't work at all. Okay, so this one does not work. Do you see why? Okay, we're plugging in these values. And this has to make this equation true. Lauren. X plus Y equals 10. So when X is 0 and Y is 10, does that equal 10? Works. When X is 1 and Y is 9, does that equal 10? Yep. And when X is 2 and Y is 8, does that equal 10? Yes, that's 3 of them. We should be good. Is there any other equations? Did you write it a different way? What do we think about that? Look it over. Does it work? X, when X is 0, we minus 10. Does that equal 10? Or when X is 1, 1 minus 10, is that 9? 1 minus 10 is not 9. It'd be a negative number. Okay? So this one does not work. Macy. Good. 10 equals Y plus X. X is about the same thing as this. Okay, they're from opposite sides. Brayden. Y minus 10 equals X. Does this work? It works. So here, X or Y. Y is 10. 10 minus 10, does that equal 0? Yes. That's good. Go to the next one. 9 minus 10, does that equal 1? No, because that's a negative number. Jason. What do you think about that one? When X is 0, 10 minus 0, does it equal 10? Yep. 10 minus 1, does that equal 9? 10 minus 2, does that equal 8? Yes, this one works as well. All right, nice job. Okay, let's go ahead and I want you to look at the one on your guided notes now under part 2. It says use the graph to write an equation that represents the relationship between x and y. Complete the table or to start. Okay, so take your information from the graph, hint, the ordered pairs, create your table, then write an equation. If you want to talk this through with someone, go for it. All right, let's come back together here. All right, what are some ordered pairs? Remember, we take our graph, we take the ordered pairs, we put it into the table. So what is one of the ordered pairs? Tom?
Y plus
Oh, that's not an ordered pair. It's an ordered pair. 5, 0. Here's 5, comma, 0. The x is 5. When x is at the 5, y is at 0. It's another ordered pair. Ella?
10 and 5.
10 and 5, which is right here. X is 10, y is 5. Macy? 15, 10 is right there. 15, x is 15, y is 10. And we have 20, 15. And we have 25, 20. So that's what your table should look like. Then, what is the equation? Patrick? X minus y equals 5. Does this work? 5 minus 0, does that equal 5? 10 minus 5, does that equal 5? 13 minus 10 equals 5. That works. What's a different one? Let's see here. Max. So 5 minus 5, that equals 0. 10 minus 5 equals 0. 15 minus 5 equals 10. It works. Another one. Tyson. That works. 0 plus 5 equals 5. 5 plus 5 equals 10. 10 plus 5 equals 15. All three of those work. All right? Okay. Next, I want you to go ahead. There's one more just like that. I want you to try this one on your own. Okay, so complete the table and write the equation from the graph. X and y, we should have x is 3, y is 0, and x is 6. Y should be 3. We have 9 and 6, 12, and 9, and 15, and 12. Okay, then what is the equation? Maddie. X minus 3 equals y. That works. Jacob? That works. Braden? X minus y equals 3. Does that work? 3 minus 0 is 3. 6 minus 3 equals 3. 9 minus 6. Yep, that works. Parker? Y equals x minus 3. Good. And that's what we're going to talk about real quick. Review from yesterday of your 8th grade material. What is the slope of that line? Maggie? 1 is correct. It's going to go up 1 over 1, up 1 over 1, up 1 over 1. All right, this is the challenge now. What would the ordered pair be of the line going through the y-axis? When x equals 0, what would y be? Patrick? 0, 1. So if I put x equals 0, is this going to equal 1? No. Aiden.
0 and 83.
You got it. What x is 0? X minus 3, so 0 minus 3 would have to be negative 3. So it goes through the y-axis down here. All right. Okay, enough of that 8th grade stuff. Let's go ahead and I'm going to challenge you with a different type of problem. And that is, I want you to find the pattern in this table. What is the pattern that is happening in this table? Talk with your neighbor. If you can find the pattern, and then write the equation. It is a little different. Work through this with your neighbors. Okay, first thing is if you are doing this, adding 2 over here as you added 1, I like the observation. But what if I said x equals 55? What would y equal? Do you want to keep adding 2 and adding 1 each time? No, that would take way too long. My hint to you, it's a 2-step equation. You have to do 2 different things, 2 operations. I'll give you like 30 more seconds. Keep your close. All right, your 30 seconds is up. Okay, that was 15. But how do we get from 0 to 1, 1 to 3, 2 to 5? 2 steps. Parker. X plus 1 equals y. He is correct, but there's an easier way to write this. Simplify that. Jason. Not x squared. Josh? Remember, x squaring is times multiply by multiply. X times x. What is x plus x? Repeated addition is, Tyson? 2x. 2 times x plus 1. So you ready? 1 times 2 plus 1. What's 0 times 2? 0. Plus 1. 1 times 2 altogether. Plus 1. 2 times 2. Plus 1. So what is the equation is 2x plus 1 equals y. Alright, I got one more for you. Yes, you need to be able to do 2-step equations, but if you have a 2-step, it will have a word problem with it, which I'm going to go over here at the end. Okay, one more. You can do this. 0, 4, 1, 9, 2, 14, 5, 29. What do you think it is? You know it's 2 steps because it can't be just multiplication. It can't be multiplication because 0 times some number is not equal to 4. 0 times some number is 0. It can't be just add 4 because 1 plus 4 is not 9. 2 steps. Okay, how am I getting from 0 to 4? Sydney. Times 5 plus 4. 0 times 5 is 0, plus 4 is 4. 1 times 5 plus 4. 5 plus 4 is 9. 2 times 5 plus 4 is 14. So the equation would be y equals 2 or 5x plus 4. Right? Okay. Last thing we're going to go over here is part 3. This is not in your guided notes. We may get to the problem in your guided notes, but I want you to follow along up here.
Suppose there is a $10 entry fee for a carnival, and each game costs an additional $2. Make a table that reflects the relationship between the number of games and the total cost.
What you need to do is write an equation that goes with this, a table, and you would have to select a graph, but just write the ordered pairs. Okay? You can talk with your partners through this. Equation, table, graph. For the graph, just write the ordered pairs. Let's come up with the equation first. Before you do your equation, you need to have 2 variables. What are our 2 variables in this problem? Tyson? X and Y. Okay, if we're going to use X and Y, we have to identify what X means and what Y means. What does X represent? Maddie? Good, the number of games. Again, this is where I'm talking about shouting out. Okay, X and Y. If you wanted to change your X to G for games and your Y to a T or a C, that's totally fine, but you have to identify it. Okay, then what's the equation for this problem? Ella? 2x plus 10 equals Y. Okay, why is it 2x? Maggie? Good. Each game costs $2. So $2 times the number of games that you play. If you play 0 games, how much do you pay for games? $0. If you play 5 games, how much do you pay for games? $10. Right? And why is the total cost? Why is it just called plus 10? Why is it just plus 10? Hudson?
Because to go into the carnival costs $10.
Good. It doesn't matter who's going in. It costs $10 to walk into that carnival. Plus 10 is called a... Think back to your vocabulary terms. It is the constant. Constant. If you're making your table, the number of games would be your independent variable. It's what we are changing. The dependent variable is the result. So if I play 0 games, how much money do I pay at the carnival? $10. If I play 1 game, it would cost me $12. 2 times 1 is 2 plus 10 is 12. If I play 50 games at the carnival, how much money do I spend? Brogan. $110. 2 times 50 gives me 100 plus my $10 in. Total cost of $110. I hope you don't ask your parents for $110 when you go to a carnival.